Hello, welcome to Solved Papers. I am Godfrey. In this video, solving Cambridge A2 Chemist. Topic is reaction kinetics. This is 2019 June exam series. Word of advice. As you prepare for your forthcoming exams, attempt topical questions. You can get the topical question from this site here, solvedpapers.co.uk. Plenty of topical questions. Topical questions is a good way of revision. Read a given topic, and when the content is still fresh in your mind, attempt questions on that particular topic for several years. That will expose you to the examiner's mind and all areas that are frequently tested on that topic. This is a sure way of making sure that a question set on that topic, you can be able to figure it out. Having said that, if you have not already subscribed to my channel, guys, please the subscribe button and hit the bell icon. This way you will be notified every time I upload a new video. Let's get started. Let's solve this question. Of course, you can use this to be able to refer to which paper the question appeared in. This was paper 4.1, May-June 2019. This was question number 5. Number 1, chlorate ions undergo the following reactions under aqueous conditions. Chloride ions undergo this reaction under aqueous condition. A series of experiments was carried out at different concentrations of chloride ions and ammonia. The table shows the results obtained. Of course, you have the table here for chloride ion ammonium concentration and initial rates in moles per dm cubed per second. Of course, 3 experiments were performed. Use data in the table to determine the order with respect to each reactant, chloride and ammonia. Show your reasoning. Of course, you are using the data from the table, using the data from this table. First, you can see in experiment 2 and experiment 3, the concentration of chloride remains the same, while the concentration of ammonia doubles. So the rate increases by 4 of ammonia. So order of ammonia with respect, order of ammonia is 2. In experiment 1 and experiment 2, you can see doubly the concentration of the reactants doubles the rate. Doubly the concentration of both reactants. You can see chloride has increased from 0.2 to 0.4. Ammonium has increased from 0.1 to 0.2 concentration. When you double that, look at what is happening to the rate. The rate has increased by a factor of 8. Of course, when you divide 2.05 divide by 0.256, most likely this will give you 8. So the rate has increased by 8. So when you take 8, you find that 8 is equals to 4 times 2, and therefore doubling the concentration of chloride ion here doubles the rate. So this is a first order reaction with respect to chloride ion. So we can show that by writing this in experiment 2. In experiment 2 and experiment 3, the concentration of ammonia, you can see the concentration of chloride ion remains the same. The concentration of ammonia doubles, and so rate increased by 4. Increased from this to this, increased by 4. right? That is when you take 820 divide by 205, this is approximately 4. So the order of ammonia here is 2. So order of 2 with respect to ammonia concentration. So ammonia concentration is order 2. When you look at experiment 1 and experiment 2 for chlorite and ammonia, I've said that you can see the concentration has increased from 0.2 to 0.4, and likewise from 0.1 to 0.2, so it doubles. So doubling concentration of both reactants, ammonia and chlorite ions, increases rate by 8, as we indicated here. Increases rate by 8. So you can say 8 is equals to 4 times 2. So doubly the concentration of chlorite ion doubles the rate of reaction. So this means concentration of chlorite ion is of first order. Very well. So here write the rate equation. Write the rate equation for this reaction. You say this is second order and this is first order. Therefore, this will be K times the concentration of ammonia. Is second order times the concentration of chlorite ion, which is first order. So that is the rate equation there. Use the results of the experiment to calculate. Use the results of the experiment 1 to calculate the rate constant K for this reaction. Include the units of K. Therefore, for experiment 1, chlorite concentration is 0.2 and ammonia is 0.1. The initial rate is 0.256. So that's what we're going to use right here. So K, if we make K subject, because you are finding the rate constant K is equals to, of course, rate. K is equals to rate divided by, let me just write a clean one. K is equals to rate divided by concentration of ammonia squared concentration of chlorite ion right there. Therefore, here we have K is 0.256, means rate is 0.256, concentration of ammonia is 0.1, you square that, times the concentration of chlorite, which is 0.2. Therefore, what we get is 128 right there. So we are using experiment 1. So here we need to get the units of K. So for the first one, we know this is moles per liter per second, that is the units of rate, divide by concentration is moles per liter, moles squared for this ammonia, moles squared dm raised to power 6 times moles dm cubed, right? So this will cancel, this and this will also cancel. So what you get here is moles raised to power minus 2 dm cubed raised to power 6 per second, right? So you can rearrange it the way you want. So this is 128, and can rearrange this one to start with the positive one. Moles raised to power minus power 6. I mean dm cubed raised to power plus 6. Moles raised to power minus 2 and per second. And there you go. Part 4. On the axis, sketch a graph to show how values of K changes as temperature is increased. Increasing temperature, the value of K increases. So if you increase temperature, because K is dependent of temperature, increasing temperature increases the value of K. Therefore, I'll draw something like this. It's not a linear increase, but all the same it's an increase. As the temperature increases, the value of K increases as well. And that's what we mean. Part B. In another experiment, the reaction between chloride ions and iodide ions, in aqueous alkaline was investigated. The solution of iodide ions in aqueous alkali was added to a large excess of chloride ions, and chloride ion concentration was measured at regular intervals. Describe how the result of this experiment can be used to confirm that the reaction is first order with respect to chloride ion. Of course, you need to plot a graph of the concentration of chloride ions against time. Against time. If the graph is having half-life, which is constant, if the half-life of the graph is constant, then that will be a first order reaction. If the half-life is constant, then the reaction is first order with respect to concentration of iodide ions. Step 3. A step 3 mechanism for this reaction is shown. Okay, we have step 1, step 2, step 3. Use this mechanism to deduce the overall equation for this reaction. Okay. We have to do this, you are encouraged to list all the reactants. Together. List all the reactants together, and all the products, also together. And then cancel the common between the products and the reactants. So here we have the reactants. The reactants here are this. So you list all those. We have that. We have water. We have hydrogen iodine ion. We have ClO. We have this. We have OH. All those are reactants. let's list the products. The products on the other end, the products are this. So I'll list here HCOL. I have OH ions, HIO. We have chloride ion there. We have water. We have ion. Then we need to cancel. We need to cancel the common between the two. You can see we have water there. We have water there. We cancel that. What else do we have which is common? We have OH here. We have OH there. And that is done with. What else is common? We have this, and we also have that. That is gone. We have this here. We also have this right there. That is also gone. We are remaining with chloride ion, iodine, up there. And here we are remaining with chloride and iodate ion there. So that is what we write here. For reactants, we have remained with this plus that, and the products we have remained with that plus that, and that is the overall equation for this reaction. Identify a step that involves a redox reaction. Explain your answer. You can see in step 2, the chloride, the chlorine oxidation here. Let me just clear this. In step 2, the chlorine oxidation state changes from this is if you go, this is -2, this is 1, +1. Therefore, the oxidation state of chlorine here is +1. So the chlorine changes from +1 to -1. You can see that to -1 right there. And so changing from plus to minus means chlorine has gained an electron, has gained 2 electrons actually. Look at iodine. Iodide, the oxidation state here is -1, and at this point this is -2, this is +1, therefore iodide here is +1. So iodide has changed from -1 to +1. So chlorine is reduced and iodide is oxidized. So you can say in step 2, chlorine oxidation state, oxidation state changes from +1 to -1, and that of iodine changes from -1 to +1. So chlorine is reduced, it has lost electrons. Actually it has gained electrons, not lost, and iodide has lost electrons, and therefore it is oxidized. So this is a redox reaction. Oxidation and reduction. It's a redox reaction. Great, you're watching this video. I encourage you to practice working out these questions yourself as I guide you. You may get these questions from this site. solvedpapers.co.uk. The site I'm talking about is this one over here. Solved Papers is a CIE site that is rich with materials. Go to A-Level Chemist 2019. Of course, you come to A2. You get to this page. You get topical questions on 2019 for both November and June. What we are dealing with is now June. Rates of reaction. You can see they are not listed here, but you'll get them in this zipper here. You click this green button here. It will open up in this site here. 2019, you have 2019 November chemist. But what you are dealing with is June. June chemist. Of course, I need you to click here. The cost is just £10. You may ask your parents to help you with acquiring these papers. You can acquire for both chemist A2. This is chemist A2 June 2019 and November 2019. You may also do the same for 2018. Of course, the cost is basically the same. Okay, there's somebody here, they have recommended this highly. They have given 5-star. These are very good questions. I also get 2017 and also get 2016. And attempt as much, practice on as many questions as you can. Of course, if you need my help, I'll be glad to help. I have got online tuition classes which I do at SP Academy. spacademy.co.uk. The site I'm talking about here is this one. This is SP Academy, Soft Papers Academy. Of course, you can take time to explore the site. These are the popular courses in the site: ICT, Mathematics, Physics, Biology, and Chemistry. And you may look at the step-by-step student guide, and also look at the watch some video to get familiar with the online live classes. And once you have made your mind, you can click here to register. You need to register to create your own account in our site. Of course, you give us the correct email address. We'll send you an email to activate your account. Once your account is activated, you can sign in, and then of course click here to find a tutor, and hopefully you'll be able to get in touch with me, and I will be glad to help you as you pursue your outstanding grades. Outstanding grades open wide the university doors. You don't need to go looking for universities. Universities will come looking for you once you score a very good grade in chemistry. Let's continue with number 2. We are told the initial rate of reaction for propanol and iodine in an acid solution is measured in series of experiments at a constant temperature, right? And this is a propanol, a ketone, and iodine in acidic media, which is serve as a catalyst to give us this. The rate equation was determined experimentally to be rate is equals to that. With propanol, this is the first order, and hydrogen ion concentration is also first order. State the order of reaction with respect to propanol. This is of course first order. Iodine is also iodine is not appearing in this, so in this rate equation, so iodine has got order 0. Hydrogen is order 1, and the overall order of this reaction is 1 plus 1, which gives us 2. The overall order of the reaction is 2. Part B, the rate of this reaction is this 5.4 times 10 raised to the power minus 3 moles per liter per second. When the concentration of propanol is that, concentration of iodine is that, and the rate of reaction of hydrogen is this moles per liter. Calculate the rate constant K for this reaction. Of course, give the units. You need to calculate K. Of course, you make K constant from this reaction here. You make K constant here. Of course, K will be equal to rate of concentration of propanol, and concentration of hydrogen. Okay, that is K. So then, of course, you bring K here. K is equals to rate. Rate you're given as this. So it will be 5.4 times 10 to the power 3. Concentration of propanol is this one, 1.5 times 10 raised to power minus 2, time concentration of hydrogen, which is this one here, 7.75 times 10 raised to power minus 1. And correct evaluation will give you K as 0.4645. To get the units for K, of course, the rate units is here, moles per liter per second, and of course the units for these, which are first order, is moles per liter times moles dm per dm cubed. Of course, this will cancel with that, this will cancel with that, so what will remain is dm cubed per mole per second. So K is 0.4645 dm cubed. Just start with the positive one, moles per liter per second. 2. Complete the table by placing a tick in each row to describe the effect of decreasing temperature on the rate constant and the rate reaction. Both depend on temperature. When you decrease temperature, the rate reaction decreases, and the rate constant will also decrease as well. There you are. Part C. From the results, a graph is produced which shows how the concentration of the iodine changes during the reaction. Describe how the graph could be used to determine the initial rate of reaction. Of course, you need to draw a tangent. Tangent is a line that touches the graph on one point. Draw a tangent on the graph. At t is equals to 0 second. Of course, then calculate the gradient. Of the tangent. That will give you the initial rate constant. Of course, the tangent will be drawn touching a graph at this point. At t is equals to 0. I draw it correctly. Touching the graph at that point 0. Then, of course, you'll find the gradient of this tangent. I'm going to draw it correctly. And then you find the gradient of this tangent. Get the gradient. You get the point? Part D. On the axis below, sketch a graph to show how the initial rate changes with the different initial concentration of propanol in this reaction. Of course, rate and propanol. This is according to the reaction here. Propanol is a first order. We say that propanol is first order right here. So a first order reaction, the rate will be directly proportional to the concentration. So you increase the concentration, the rate will also increase. So the graph looks like that. Part Part E, the rate of the reaction between the metal ions was studied. The following three-step mechanism has been suggested for this reaction. Step 1 is the rate determining step. Step 1 is the rate determining this step. Alright, before we get out of this, I must mention that for first order reactions, here, for first order reaction, like it is for propanol, for first order reaction, the rate against the concentration is a straight line through the origin. Straight line through origin. Needed to mention that. So our first order, our first step is the rate determining step. We are told that the first step. So the rate, explain what is meant by rate determining step. Rate determining step is usually the slowest step in the mechanism, in the reaction mechanism. In a reaction mechanism. Use this mechanism to determine the overall equation for this reaction. Use this mechanism to determine the overall reaction of this mechanism. So basically what you need to do is list all the reactants. List all the reactants and all the products, and cancel the ones that appear the same time. So the reactants there are this, and this. So we have Ce4, we have manganese there, we have C4 again here, so we don't need to write it again. Then we have M3 there. We have M2, M4, Mn4, and we have T plus. Then the products are C3 plus, Mn3 plus, C3 plus is appearing second there, Mn4 plus, we have TL3 plus, and we have Mn2 plus. So you cancel the ones that appear in both sides, in both reactants, and species that appear in both reactants, and we have that. We have this. We have this. We don't have that. Yeah. So and don't forget these are 2, and these also are 2. Because there is 1 and 2, and there is this and this. So this will be 2, this 4 plus what is remaining, which is TL plus. Then what is remaining is 2, C3 plus TL3 plus. Therefore, there you have your overall equation right there. Suggests the role of manganese 2 ions in this mechanism. Explain your answer. Manganese 2 is behavior as a catalyst. You can see manganese 2 is it is the one which started the reaction here. Manganese 2 is there, and it is gained back the end of the reaction mechanism, and therefore it is behaving as a catalyst. So manganese 2 is a catalyst. It is not consumed in the reaction, so suggest a role and explain your answer. It is used in step 1, so you can see right here, it's used in step 1 and then regenerated, and then regenerated again in step 3. So in that way it is used as a catalyst. It is not consumed in the overall reaction. That is it, guys. Those are the questions that were set on rates of reaction for June 2019 series. Get more topical questions to practice with from this site, softpapers.co.uk. If you need my assistance for further, you can get in touch with me in SP Academy, spacademy.co.uk. I'll be able to be of help to you. Hopefully, let's meet in my next video. Cheers.